Scientific notation. Although it may seem like this subject is more related to math, but actually chemists deal most of the time with a very large numbers or a very small numbers. For example, if I looked at 1 gram of element hydrogen, it is actually equal 602 multiplied by 21 zeros. As for the atom, hydrogen atom, it has a mass of only 0.2700166. I can use a simple way to write those numbers by using a formula that says that my number is actually equal n multiplied to 10 to the power n. For the first one, we could say that it is actually 6.02 multiplied by 10 to the power 23. As for the second number, I can just simplify it by saying it's equal 1.66 multiplied by 10 to the power minus 27. Significant figures. The significant figures is important because it allows us to understand the number that we are obtaining during our calculation. Example for that, if I have 5 written as 5.00 multiplied by 10 to the power 2 gram, I may look at it same as 5.0 multiplied by 10 to the power 2 gram, and it would be similar for me if I looked at it 5 multiplied by 10 to the power 2 gram. Actually, there is a large difference between those. This would tell me that this first number is actually have 3 significant figures, which means if I have here a fraction, I should consider the 2 numbers that in here, if I have something either but 0, if I have like 51 or 32, so all these numbers should be considered because I have 3 significant numbers. As for the second case, the number 5.0, although it may look like the first number, but the point here gives us indications that my significant number in that case would be 2 significant numbers. These 2 significant figures, this means I should consider these 2 numbers only. In third case, I could see that the 5 is written by itself without any pointers. This means my significant number is 1 significant figure. This means if I have this number, I have an error, positive or negative, 5.01. My error would be 0.01. But in that case, my error could be 0.1. The error in this case would be positive or negative 1. I could say this is the highest errors that the highest numbers that can give me errors. Handling number. So like we said, scientific notations mean I can write the number as the form of n multiplied 10 to the power n. If I express this in significant notation, something like, example for that, if I write 0.012341114, this means I can write it as 1.14 multiplied to the power 10 to the minus 1. Here comes a question. Why I wrote the number as 1.14? Why I didn't write something like 11.4 multiplied 10 to the power minus 4? It comes to a rule that says my numbers, the numbers that on the left side of the point, it should be of the decimal numbers, it should be between 1 and 10. So I cannot write this form because it says 11, which is larger than 10. Now, another example, if I'm looking at number like 568.762, if I'm writing the notation number for this number, this means I have to start my notation from this point to have only 5, which lies between 1 and 10. So it would be 5.687 6, 2. Multiplied by, I moved my decimal to two numbers, which means multiplied by 2. So 10 to the power 2. Now let's look at how I can do addition and subtraction to my significant numbers, or to my notation numbers. If I have example like 7.4 multiplied by 10 to the power 3 plus 2.1 multiplied by 10 to the power 3. Here 10 to the power 3, and in that case 10 is the power 3, so there is no problem with that, so they have the same numbers. If 10 have the same numbers, this means I can just sum the individual numbers that comes on the left, which means 7.4 plus 2.1, which is equal to 9.5, multiplied by 10 to the power 3. This means my 10 to the power 3 remains as it is, without any changing. This is how I do addition. But if I'm doing subtraction to a number like 2.22 multiplied by 10 to the power minus 2. If I'm subtracting from that number 4.10 multiplied by 10 to the power minus 3. Here we could see that I have different 10 to the power, here is 10 to the power minus 2, and here is 10 to the power minus 3. So how can I do that? First, I have to make 10, the number on the power of 10 should be the same. So I would like move my point in that case. So I will leave the first number as it is, 2.22 multiplied by 10 to the power minus 2. Minus, I will change this number to move my decimal to be 0.410 multiplied by 10 to the power minus 2. I moved this point in here. I didn't move it from there because if I move it on that one, this means I will move it just to be 22, which is a very large number, while 0.4 is still a smaller number than 22. So the answer would be, in that case, I would sum 2.22 plus 0.410, which is equal to 2.11 multiplied, in that case, because I have here multiplied by to the power minus 2 and here multiplied by to the power minus 2 multiplied to the same number. So I don't do like any addition or any subtraction to the tens. So my answer would be 2.11 multiplied by 10 to the power minus 2. Multiplication and division. If I'm looking at multiplication and division, if I looked at multiplication, if I try to multiplicate number like 8.0 multiplied by 10 to the power 4. If I multiplied by another number which is 5.0 multiplied by 10 to the power 2. In that case, when I do multiplication, I add the numbers that lies above the 10, which means I will multiply 8.0 multiplied by 5.0. I would also add the numbers in here, which is 4 plus 2. So the answer to that would be, here would be 40. 8 multiplied by 5 is 40. Multiplied by 10 to the power 4 plus 2 is equal to 6. I should remember that my number in that case in here should be between 1 and 10. So I would move a point, I would write a point here and move my decimals to this side. So it would be 4.0 multiplied by 10 to the power 7. You have to remember, when you put the point in that position, you are adding another number to your power. But if I move it in that direction, it would be by minusing. Example to that. If I looked at 4.10, if I multiply it by 10 to the power 2, if I moved my decimal numbers to be in that direction, so I moved it to that direction, this means I will end up by 0.410 multiplied by 10 to the power 3. But if I moved it in that direction, this means my number would be 0.4110 multiplied by 10 to the power a minus number from this one, which means this would be to the power 1, which is actually 41 multiplied by 10 to the 10. So I have to remember, moving my decimal to that direction is minus, to that direction is plus. Now moving to division. If I want to divide something like 8.5 multiplied by 10 to the power 4. If I want to divide this one by 5.0 multiplied by 10 to the power 9. In that case, I will divide this number by this number, and for the tens, I will subtract the 9 from the 4. So I have 8.5 divided by 5.0 multiplied by 10 to the power 4 minus 9. So the first number would be equal 1.7 multiplied by 10 to the power 4 minus 9 is actually equal minus 5. Now let's sum some rules of the significant figures. First, my significant figure, if I have something like 6 plus or minus 1, this means plus or minus 1, my number lies between 5 and 7. While if I said 6.0 plus or minus 0.1, this means my number would lie between 6.1 and 5.9. Any number is not 0 is a significant number, which means if I have 8.2, this is two significant number. If I have something like 85, this is two significant numbers. If I have 0 between non-zeros, it would be a significant number, which means if I have something like 40,501, this 0 is counted to be a significant number, and this 0 as well should be a significant number. So my significant number here is 1, 2, 3, 4, 5. I have 5 significant figures. Now, if I looked at 0 on the left, 0 on the left would be non-significant, which means if I have numbers like 0.08, I have the zeros on that side, which is the left side. So how many significant figures I have here? It would be only one significant figure. While in case of I have the 0 on that side, which means if I have something like 0.09050, I look at any 0 on the left side as non-significant figures, the 0 between any number as significant figure, and the 0 on the right should be a significant figure. So this number have how many significant figures? 1, 2, 3, 4. So here I have 4 significant figures. Point. Now let's talk about rounding of numbers. If I have number like 0.14, I can round it off. If I want just one decimal, I would round it to 0.1. But if I'm rounding a number like 0.16, I would round it off to 0.2. The difference between two is that 4 lies between 1 and 4, while 6 lies between 5 and 9. If I have the number here lies between 1 and 4, I'm not gonna add any numbers. But from 5 to 9, I would add 1 to the number beside it. Now let's look at if I'm doing addition, how can I round off numbers? In that case, in my first example, the answer is actually 11,254.2983. If I want to round off this number, I would round it off to the number which have the least decimal numbers, which is 0.1. So my number would be 11,254.3. I add 1 to the 2 because it is the 9 lies between the 5 and 9. In case of subtraction, it's similar to that. So if I'm doing rounding, so I will use the number. I will use the numbers that have least decimal numbers, which is in that case this number. So if my answer is actually 63.477, this means if I rounded this number, I would round it to 2 decimal numbers, which means 63.48. I also add 1 to the 4 because 7 lies between 5 and 9. In case of multiplication and division, it's a little bit different. I have to look at how many significant numbers I have. In here I have 3 significant numbers, while in here 1, 2, 3, 4, 5, I have 4 significant numbers. So my answer should have the least significant numbers, which means my answer should have only 3 significant figures. So in that case, if the answer 41.90568, rounding off this number to only 3 significant figures would be 41.9. In case of division, it is similar to multiplication, so I would have to count the number of significant figures. 1, 2, 3, I have here 3 significant figures, and here I have also 3 significant figures. So my answer would be 0.001740546. To round this off, I have to round it to only 3 significant figures, which is 1.74, and multiplied by 10 to the power. I moved the point here 1, 2, 3, 4 numbers, which means minus 4. You have to remember when I move my point to that side, this means I have to multiply to the minus, and here I will have to move it with a plus sign. In case of last example, if I have addition of numbers that have 2 different my 10 to the power number is a little bit different. So here I have 3 and here I have 2. So I have to keep them the same, which means in that case, I would move one of these points. So I have 10 to the power 3 in both of them. So first number, I'm not gonna change it, multiplied by 10 to the power 3, plus, in that case, I would move my point here to be 0.327 multiplied by 10 to the power 3. Because I moved my point in that direction, I add 1. In that case, the answer would be just adding these 2 numbers, and I will keep my 10 as it is. So 10 to the power 3 is unchanged, and the addition of these 2 numbers is 2.97. I used only 3 numbers because I started with only 3 significant figures.